Okay, so what we're going to do now is we're going to have a look at finding the tangent passing through some fixed point. So sometimes we want to find the equation of a tangent to a curve y is equal to f of x. So it's just some curve passing through a fixed point f in the plane. So that is, if we have some, some curve like this, okay, and we might say, for example, I want to know what, the tangent at this point here, I want to know what tangents pass through this point here. So it might be like this one that goes like this, or it might be, the one that's really steep up here that goes down like that. But if it actually gets there, like we're trying to find all of the points that the tangent goes through, or all the possible tangents that go through a specific point. So this problem can be solved by finding the equation of a tangent at a variable point P, where the point is made up of a new variable t and the function variable t. So that is where the point is t, and then the function variable at t, value t. And then substituting the coordinates of f into the equation that we make, and then the method can be applied to other similar problems. Okay, so let's jump into and see how this is done. So what we're going to do first is we are going to find the equation of the tangent to y is equal to x squared minus 3x plus 4 at the point P on the curve where x is equal to t, and then hence find the equations of the tangents to the curve passing through 0, 2, and the corresponding point of contact of each tangent. And what we'll do after is we'll have a look on our Desmos and see how this works. So let's start off with part A, finding the equation of the tangent. So quite simply, if we've got y is equal to x squared, I think it's minus 3x in this case, yep, plus 4, then to find the tangent, I hope you're getting the hang of this, I'm going to do dy dx. So that's 2x minus 3, okay? Now, what we want to do is we want to find it at this particular point P, so where x is equal to t, we get dy dx is equal to 2 lots of t minus 3, or which is just 2t minus 3. Okay. Now, the coordinates, so the specific coordinates at P are, and remember P is just made up of the function value t, and then of t, and then the function value at t, so x squared becomes t squared, okay, minus 3t plus 4. So this is basically like a point. I say that in inverted commas, a point. But it's a bunch of points where whatever t value I substitute in, it makes up every possible point in my equation. So think of it like back to our parametric equations where, one value it makes up a coordinate. So if I say t is equal to 1, okay, it's going to give me an x and a y value that corresponds to a t value of 1, and so on. Okay, so the tangent then becomes, okay, so what we're going to do is we're going to substitute this into our y-intercept form, okay? So we get y minus, now our y value, so our y1 is this guy up here. So it's going to be t squared minus 3t plus 4. And what we're going to do is when we substitute all these t values in, is we're going to get an equation that's based in t, so this new variable that we're using, that's going to give us all of our different points along the tangent. So 2t minus 3 is the tangent, the gradient, because we know that from the derivative, and it's going to be x minus, and our x value, or x1 value, is t. Okay, so the reason why we don't use t is because, well, x minus x is just 0, and it makes this whole thing completely redundant. So we need to pick a new point, so a made-up point, t. So what we're going to do next is we're going to expand this out. So we're going to get y minus t squared plus 3t minus 4. That's going to be equal to, so it's 2tx minus 3x, so that's this one and this one, and then we're going to do that one and that one for our next one. So that's just, like, there's a particular reason I'm doing it this way, so let me just jump those back out, and you'll see why in a moment. So then it's going to be minus t times 2t, which is minus, 2t squared, and then it's going to be minus 3 times negative t, which is positive 3t. Okay, so I'm going to get the green out, and I can see I can cancel that, because if I subtract negative 3t from both sides, I get that. And what I'm going to do is I'm going to add I'm not going to add 2t, I'm going to add t squared, and I'm going to add 4 to both sides of this equation. Okay, so that's going to give us y is equal to, now 2tx is going to stay unaffected, so it's the negative 3x, but the plus t squared and the minus 2t squared, well, that's going to become minus t squared there. And the next point is the point, so we get minus t, so it's going to be just the plus 4 on the end there. Yeah, just like that. Now, what we're going to do next is we're just going to take a factor of x out. Okay, and that's why I put the x's together to begin with. So we get this gradient, 2t minus 3 of x, and then our y-intercept is minus t squared plus 4. Now remember, this is the equation in y and x where any variable t makes this true. So, if I find t is equal to 1, it's going to tell me exactly whereabouts on the the graph I'm going to be. Okay, and so that's the end of part A. Now, part B is to then find the equations of the tangents to the curve passing through the 0, 2, passing through the 0, 2, so passing through 0, 2, and the corresponding point of contact of each tangent. So if we have a look at this one here, okay, so if we have a look at this one here, so this equation here is the equation of every single tangent of the graph, okay? Again, where if we substitute a value of t in, it's going to give me a tangent at that point t, okay? So what we're going to do is we're going to, if I can find where my pen has gone, okay, we're going to work out by substituting, wow, that was horrible, and we're going to substitute our point. So the point that we want to find is at 0, 2. So we're going to sub 0, 2, okay? So it's where I see a y, I'm going to replace it with 2, and that's going to be equal to our x value, so 2t minus 3, lots of 0, so it's going to cancel out, it's going to leave me with minus 2 squared plus 4. Okay, so from this point onwards, we're going to say, well, that's going to disappear completely. I'm going to be left with 2 is equal to minus t squared plus 4. What I can move is move the t squared to this side, and it's going to give us, if I subtract 2, it's 2. So t is equal to square root of plus or minus 2. Okay, so these are the values at where the tangent is going to go through the point 0, 2. So to find what the actual equations are, is, so we're going to say, well, when t is equal to, okay, the positive square root of 2, okay, the tangent becomes, and what we're going to do is we're going to substitute the square root of 2 into this tangent equation up here. So we're going to get, okay, so y is equal to, it's going to be 2 lots of the square root of 2 minus 3 lots of x, okay, minus, and it's going to be t, well, it's not going to be t squared, it's going to be the square root of 2 squared plus 4. Okay, so y is equal to, so it's going to be 2 root 2 minus 3 of x minus, okay, so 2 plus, negative 2 plus 4, well, that's just plus 2. So that's the first equation of this point. So if we have a look up on Desmos now, here's the equation. The point I'm wanting my tangents to go through is 0, 2, so it's this point here. Okay, and the first equation we've got is y is equal to, now it's going to be 2 root 2, well, square root 2, minus 3x plus 2. And what you can see is I've got this point on my graph here, okay, which is at the value, well, if I work out what that value is, what we would do is we would substitute the square root of 2 back into, whoop, you guys can't see this, we would substitute the square root of 2 back up into this initial equation. So root 2, comma, 2 minus 3 root 2 plus 4. Okay, so if we substitute it back into there, it will give us this point here. Okay? And that goes through. So this line, this black line, is the tangent, and it goes through that point 0, 2. Now, for my second one, we're going to say, well, when t is equal to negative square root of 2. Okay, so the tangent for this one becomes, and it's going to be y is equal to 2, well, it's going to be negative 2 root 2 minus 3 lots of x minus, and then the 2 root 2 thing is just going to become positive again, and it's going to be this one here. Okay, so putting it all together, we get minus 2 root 2 minus 3 of x plus 2, just like that. Okay, so again, if I now put this equation on the graph, oh, sorry, you couldn't even see any of that. Oh, God, I'm getting really bad at this. So just again, so I'm going to substitute t is equal to negative root 2, okay? So I'm going to substitute it back into this tangent equation that is over up here. Okay, the one that I've got underlined up here. Okay, so it's this guy here. So what it's going to become is y is equal to, and it's going to be negative 2 root 2 minus 3 lots of x plus, okay, so think of this one up here. So minus 2 root 2 squared is just 2. Okay, so minus 2 plus 4 is just 2 again. Okay, so it's that point there. So what we're going to do now is if I click back onto Desmos, okay, we're going to put this new point in, minus 2 square root of 2 minus 3 x, and it's going to be the plus 2 again. And what we'll see is we get this tangent going along here again, okay, that goes through to point 0, 2, which is just this one here, okay, and the tangent for this line meets here. And again, if we wanted to find where that point is, okay, we're just going to substitute negative square root of 2 back into here. So sub root 2 and negative root 2 into here, and that should be t is equal to and t is equal to. Okay, and that gives us our point where where our tangent's going to be. So with that being said, that is the end of this video. Okay, so keeping in mind that this one is a bit trickier to do, but once you sort of get the hang of it, it's an algebraic process that will help us find any point or any tangents that go through any points. Okay, so tricky question, but one that we can do.